Today we'll be discussing related rates. I'll give you an example problem and then we're going to work through it. So, a young child is flying a kite horizontally 120 feet above the ground. The child lets out 2.5 feet of string per second. If we assume that there is no sagging the string, at what speed is the kite moving when there is 130 feet of string out? So first, let's draw our kite. So it says the kite is flying horizontally 120 feet above the ground. So we can assume this is 120 feet, which is given to us. And he lets out the string at a rate of 2.5 feet per second. We'll get that to you in a sec. And there's no sagging string. At what speed is the kite moving when there's 130 feet of string out? So the string is actually going to be allowed this way because when you fly a kite, the kite goes in this direction. So this is going to be 130 feet. So, okay. So first our givens are the x, we'll call this x, call this z, and we'll call this y. So our x, which is the height, is 120 feet. Our y, which is the length of the string, is unknown. Length of the string horizontally is unknown. This is what we're solving for. We're solving for the rate of change for this, the dy dt. And our other known is how much string is let out, rz, 130 feet, which is the string let out. And so, our equation we're going to use is x squared plus y squared is equal to z squared. So first, let's find a derivative of this implicitly. So 2x dx dt plus 2y dy dt is equal to 2z dz dt. Right. So first, let's see, what do we have given in this equation? We're solving for the dx dt. The dy dt. We're given our 2x. We're given the dx. We're not given the dx dt. We're given the z, and we're given the dz dt. So let's see. So 2 times 130 dz dt, which is given to us in the equation, is going to be 2.5 feet per second, because that's the rate at which he releases the string. Okay, so we can plug that number in, 2.5. The x is 120, 2 times 120, plus, if we use Pythagorean theorem, we can figure out the y, right? 120 squared plus y squared is equal to 130 squared. So y is going to equal 50. I already have this calculation done. I'll just do it just to save time. So 2 times 50. Oh, sorry. 2 times 50 dy dt. You might be wondering, what is the dx dt? Well, since the kite is moving at a rate of, since this part is not changing right here, it's constant at this 120, right? So it's actually going to be 0 over here. So it comes out to be dy dt is equal to 2 times 130 times 2.5 divided by 100. Yeah. So you can simplify this. dy dt is going to equal 6.5 feet per second. So this is actually the rate at which the kite is being the kite's changing in this direction up here, because the question is asking for what speed is the kite moving. So the kite moves over here like this, and this is the rate at which the kite's being released. The string is being released. This is the rate at which it moves, and this right here is going to be constant because the height at which it is not going to change. Okay, thank you.